So hello everybody. Today I'm going to give you a review about how to solve the problem set in the exam 3. So in the exam 3 we cover chapter 12 to chapter 7, right? So here is my syllabus for the exam 3 here. We cover the chapter 12, which is the introduction of ANOVA, and then chapter 13, which is the repeated measures ANOVA, chapter 14, the two-factor ANOVA, chapter 15 and 16, regression and correlation, and chapter 17, the chi-square statistic. So in this example right here, we have one question for the independent measure one-way ANOVA, one question for the repeated measure ANOVA, and one question for the two-factor ANOVA, one question for correlation and regression, and the last question for the chi-square statistics. So let's go through the question one by one. Here is the first question. So let's read the question first, right? The following data are from the study examining the influence of bedroom colors on people's sleep quality as a 1 to 10 point scale. So this is the data. So you can see here the influence of bedroom colors. So this one, bedroom color, is the independent variable. So which independent for a variable for ANOVA, right? The independent variable is the factor in the design. So here we just have one factor, which is the bedroom color. And what's the data in this table, right? So this column, this row is the category of the bedroom colors, which is the independent variable. So those numbers here are for the dependent variable, which is the sleep quality. So the sleep quality is what we measure, use the 1 to 10 point scale. So this number, if you remember the notation, right? For ANOVA, T is the total, the condition total in the rosy condition, and SS is the sum of square of this condition, and the M is the mean. FC is the standard deviation, right? So the G is the grand total, means the total across all scores. And sigma x squared is the sum of, if you compute the square of each score and then we compute its sum. So because we have one factor and more than 2 levels, 3 levels in total, 1, 2, 3 levels. So more than 2 means we cannot use just the t-test. We have to use an ANOVA. Then we have one factor, so this is a one-way ANOVA. Let's read the question, right? If 3 groups of participants are recruited, one group with 10 participants for each condition. So we can see here the keyword is 3 groups, one group for each condition. Means in each condition, so rosy, green, and blue, the subjects are different, right? We call this kind of design as an independent measure design. So what type of analysis should be used to test the hypothesis? As we said, it's an independent measure design, so the answer is independent measures. And then we said it's the what? one-way ANOVA because we have just one factors. One, okay. One-way ANOVA. So you should write the full term in the exam. Independent is because we have different group of participants in different conditions, right? One-way ANOVA because we just have one factor and more than two conditions, so it's an ANOVA. All right. So if we know the one-way ANOVA, we should use the chapter 12. Chapter 12, use these formulas. And the second question is to fill out this summary table. So if we read the hypothesis testing part of chapter 12, you can have all of the formula to solve this, which is, let me check the book. Repeated one-way ANOVA. You can check the book, right? From page 386 to 39. So we need to compute the SS, DF, and the means, the MS means the variance, right? And F to fill out this summary table. So for independent measure ANOVA, we have two sources of the variance for the total variance to compensate the total variance. The first one is the between treatment variance, and the second one is the within treatment variance. Their sum are the total variance. Also, for it's DF, right? The sum of these two DF is equals to the total DF. The MS equals to SS divided by the DF in the corresponding row. So let's start with the total SS total. Here's some return, and I will show you how to solve it step by step. So let's open the checklist. Where's my checklist? Checklist. Chapter 12. Here I have all of these formulas. I just copy and paste the formula. So start with here, formula and summary table, total, right? SS total equals to sigma x squared minus g squared divided by n. So you check the data. Give me 1 minute. Yes. Here we have all of this information. So sigma x squared, we have the numbers, right? 2242.5 minus g squared. G, we have the numbers here. 225, and it's square. So the n, so here we see we have three conditions, right? And one group with 10 subjects. So here we know. Where's my mom? n equals to 3 times 10, which equals to 30. So we also know n. And here, which is 30, how many subjects in total? Right, you just use your calculator to compute. And we know this number equals to 75. Right, finish this one. And the DF total equals to so put this number here, 75. And the DF total equals to n minus 1. It's simple, 30 minus 1, right? Which is 29. Here, the return. And then let's start with the SS, right? The SS of the within treatment. So the within treatment is equals to the sigma SS square. SS square. So we have those numbers here. So it's not SS square. Why I wrote as SS square equals to SS, no square, just SS. SS. So just a simple calculation equals to 27, right? This SS and plus this 16 plus 23, which equals to 66. Put the 66 here. And its df equals to the sigma of the df in each condition. So for each condition, the df equals to n minus 1 for each level, right? So here, the n is the number of subjects in each condition, which here n equals to 10. Small is a lowercase n means the sample size. Okay, n equals to 1. Times how many levels do we have? 3, right? 3 levels in total. So which equals to 10 minus 1. 10 minus 1. Times 3, which equals to 27. So put 27 here. So we finished this part, right? The S for the within treatment. So we can also compute the MS within, which equals to the ratio between its SS and DF. Here equals to 6 divided by the 27. So replace this number divided by this number. So which equals to 2.44. Put the 2.44 here. 2.44. Okay. So after we finish this, how can I connect them together? View. So let's compute the between treatment part. So this is just a simple subtraction, right? The SS between equals to this number, the SS total minus the SS within, which just equals to this number, 75, minus this number, 66, which equals to 9. We put the 9 here. And do the same thing for the DF, right? This number minus this number. 2. Put 2 here. And the MS is the ratio between the SS and the DF. Which equals to 9 divided by 2, which is 4.5. Put 4.5 here. And we can finish this part, right? So the F ratio, check here, equals to the ratio between the MS between treatment and MS within treatment. So just the ratio between this number and this number, which equals to what's that? 4.5. Make it smaller. Yes. Okay. 4.5 divided by the 2.44. So which equals to 1.84. 1. Why press 2? Okay, so here we need to report the F together with its degrees of freedom. So the first degree of freedom, which is the degrees of freedom of the denominator. The denominator is the between treatment component, right? So it's 2. 2. And the second number here is the DF of the denominator, which is the within treatment. And here should be 27. So the F ratio, this number I will just compute it, is 1.84. So we have our answer. So we finish, right, this table. And the next question, do the data provide evidence supporting the significant influence of the background color on sleep quality? Use the alpha equals to 0.05. Please answer yes or no. So this question asks us to make a decision, right? Which is the fourth step of the four-step approach, hypothesis testing. So here we know its F value, and to make the decision, we have to know the critical region. So the critical region here is a F distribution. It's an F distribution. Is DF1. DF1 is the DF of the denominator, which here we know is 2, equals to 2. And DF2, which is the DF of the denominator. Here we know is 27, right? 27. And we know its alpha equals to 0.05. So check 3.4. which is on your page. So let's go to the page 653, which called is the T distribution table, right? So we need to check the number with DF1. So I have some table, but it's better to bring your own table. So it looks different. So on the book, the appendix B.4, right? So the light phase type are for alpha equals to 0.05. So this is just that component. We check the df equals to 2 and df2 equals to 27. So it's here, right? Their cross should be alpha. Oh, where is it? Greater than 3.2735 is the critical region. Okay, we have our answer. And then let's check whether or not our data, right? Our alpha equals to 1.84, which is not in the critical region. So we fail to reject H0. So if you don't understand this part, when we need to reject H0, when we fail to reject 0, right? You have to go back to ask me, which is the most important part in the cycle 107. So when your statistic value is not in the critical region. And then you fail to reject 0, which means the influence effect is not significant. Let me see now. So the answer here, not significant, no, right? Please compute the eta square to measure the effect size. So effect size is the proportion of variance can be explained by the treatment effect. So here you just check your book, the effect size, which is page 389. We have the formula. So here we also have the formula. Eta square equals to SS between treatment divided by the SS total. So we have all these numbers, right, in that summary table. SS treatment have this number 9 between treatment, which is 9, and SS total, which is 75. So just do the computation, which equals 0.12. That's it. Okay. Yeah, we finished the question 1, right? So this is question 2. So we changed our data set if only one, what color did I choose? Only one group of 10 subjects are excluded n equals to 10. So with each subject, each participant testing all of these treatment conditions. So this is the description for the data in the repeated measure design. In this kind of design, we just have one sample of subject, right? So each subject we test he or she several times. For example, here we test them 3 times in 3 rooms, right? In each room with different 3 kind of colors. So I just said it's a repeated measures design. So it's a repeated method. We still have one factor, right? It's one-way ANOVA. One factor more than 2 levels. So it's a repeated method, one-way ANOVA. So we answered the first question. And just give me some space, easier to do. So we have another summary table that looks different as the previous one. So we can check. The previous one looks like this. So you can see here, for the within treatment part, we separate this component into 2 sources. One is the between subject, another one is the error turn. So here means which is the stage 2 of the repeated measure ANOVA. So for this one, if you want to read the book, right, we check you need to read page 422 to page 426, your textbook. So here means the first step, the first stage of the repeated measure ANOVA is identical as the independent measure ANOVA. And the second stage will remove the between subject variance from the within treatment variance. And the leftover is error term here, which is the denominator of the F ratio. So this is the basic logic for the repeated measure ANOVA. So I just said the first step is identical as the independent measure ANOVA, right? Because we have the same data. So it's identical means we have the same result. So it means the first step, we separate the total variance into the first stage. Into between treatment and so here you can just copy these numbers. Total, right? The first one is total. It's the same number. And within, you don't need to compute again. Just use what you have in the previous table. You don't need to do the computation again. So, and then the next part, the second stage, remove the between subject. Which is the denominator of the F ratio. So how to remove, right? So this one, okay, let's close this chapter. So because it is a repeated measure of Womay or NOVA, right? So, and then we need to use the checklist. Chapter 14 to find the formulas. Not 14, why is that 14? 13. So here you don't need to do the step 1 again, right? Because they are identical. So, and then we just need to do the stage 2. Actually, the stage 2, right? The SS between, I give the data to you, the number to you, so you don't need to compute again. But you need to know its degrees of freedom. So its degrees of freedom. Oh, I missed this one. EF equals to K minus 1. Not K, N minus 1, sorry. N is DF between subjects. Yeah, between subjects. So let's copy this formula right here. This one I gave you the numbers, so you don't need to compute. So we just need to compute the DF between subject, which equals to N minus 1. So you make sure here N is the lowercase n, not capitalized N. The lowercase n equals to 10, which is 9. Put 9 here. And then arrow turn. Right? Arrow turn, you have this formula. The SS arrow equals to the SS within treatment minus the SS between subjects. So just means this number minus this number. 66 minus 46 will be 20. And then it's DF, right? We have the formula equals to K minus 1. K is the number of conditions, number of levels. So number of levels, we have 3 levels, right? 3 different colors. And N minus 1, 10 minus 1, which is 2. And also you can check here, this number minus this DF, right, equals to the DF within treatment. Just to double check. Make sure your computation is correct. Don't make the omission error. So let's compute this. The MS, right, just we need to fill out the gray area, just this one. So if it's in white, means you don't need to fill out anything in that cell because we don't need to compute. So let's compute the MS arrow. SS arrow here. This number 20. Sorry, divided by 18 equals to 1.11. here, or is this 1.1? So it doesn't matter. 1.1. So here is the df of the denominator, the numerator. Sorry. So the second one is the first one is here, right? The numerator of the f ratio, and the second one is the df of the denominator of the f ratio, which is the error term. So which is 18. So the f ratio, we have the number, the answer here computed. Oh, not computed yet. Yeah, use this formula. So if you are very confident on your answers in the exam, you don't need to write down these formulas. You just need to fill out this table. But if you are not very confident, you can write down those formulas. I can give you half of the points, even if your answer is wrong. But first, you need to write down the correct formula. Otherwise, you don't have the point. So MS between, right? Which is, just search the table. 4.5, here 1.1, here error term 1.1. So the answer here equals to 4.05. 4.05. So okay, we finished the question 2.2, right? Next one, which is make a decision. So means we need to check the table again. So here, let's check what do we need. The critical region of an F distribution of let's copy this, but we need to revise something. Critical region of, you can check df here, 1, and this one is not 27, it's 16. Make sure you change the degrees of freedom to 16. 18. Why is it 16? 18 because it's a within subject design. The degrees of freedom are different. It's for the error term. Make sure this one, very important. Make sure this one is correct. So check the table. 2 and 18, which should be 355, right? F greater than 355. So here our F equals to 4.05, which is in the critical region. So we reject H0, which means the treatment effect is yes. Okay. Sorry. We finished the question 2.3. Last one, to report the result in APA format. So here, just to save time, we don't need to conduct any post-hoc analysis. Actually, in the lecture, I just said if the F test is significant, and then we need to do the post-hoc analysis. But here, because it is an exam, we have a very limited time, so we skipped the post-hoc analysis. But if you are writing the formal paper, right, you have to do the post-hoc. Let me write the sentence with the repeated measures. ANOVA, that's the statistic method we used. Showed what, right? We go back to check our problems. So showed that the background color had significant influence on people's in people's what? In people's sleep quality. So this is our conclusion, right? F, go back to the table. Here, italic, F2, comma, 18 equals to 4.05. Because it is significant, so P smaller than alpha. It means alpha because alpha is equals to alpha with alpha is 2.5, so its P is smaller than 0.5. That's it. Just one sentence. Very simple, right? So yeah, because it's an exam, we don't have time to report all of the post-doc part. Just stop here. Okay, let's finish. We already finished the two problem set in total, which deserve, I don't know how many points in the exam. I think a lot. Okay, so we finished chapter 13. Let's start to do the next problem set. So here, read the question first. The following result are independent measures, right? We know it's an independent measure. Two-factor study. Okay, I told you it's an independent measure. Two-factor study with n equals to 10, which is the sample size. So two-factor independent measure study. Here, two-factor ANOVA independent measure, which is chapter 14. Open chapter 14 checklist to find out all of these formulas. So here, which is the design matrix, right? To read this design matrix, we know the row are the factor A, which have the A1 and A2. So the column is for the factor B. For the left side is the B1, right side is the B2. T is the total in this cell, means A1 and B1. So M is the mean, SS is the sum of square. So for each row, right, we also have the row total, the row mean. And for each column, we have the column total, the column mean. So this is total number of subjects, the grand total, and the sigma x squared. So the first question, right, to compute the main effect of factor A. I don't have this one documented. So let's check our slides. Chapter 15. Here. How to compute the main effect, the magnitude Also, you can find all this answer in the textbook, which is which page? Let me check. Page 4 from my slides, PowerPoint. So here we can use this formula. Means the magnitude of the main effect of factor A. Actually, the main effect is the difference, right? Factor A is the difference between rows when ignoring the factor B. So means it's the mean, the difference between these two numbers, which is 1 point. The main effect of factor B. B2 and B2 minus and B1 equal to 3 minus 2 equals to 1. Next page, which is the interaction effect, right? You can use this formula. Copy. Oh, don't crash. Just copy. Okay, didn't crash. Good boy. We can see here is this number 5 minus, right, the number on the same row 2 minus the effect of the B on A1, which is 1 minus 4. So means 3 minus negative 3, which is 6. So that's the answer. This one, let's figure out the table again. So you check your textbook, page 460 to page 464 for this part. We also have the formula here. Give me some space. The stage 1, right? Separate the total variability into 2 components within treatment and between and within treatment. So let's do it. Compute the excess total first. The number here. Sigma x squared equals to minus the g squared. G equals to divided by n equals to 40. Which is put the number here. And the degrees of freedom equals to n minus 1. That's simple. And capitalize n. Make sure it's capitalized n, right? Which is 40. to 39. Put 39 here. And then separate to two components between treatment and within treatment. So let's do the within treatment first, right? Why is still have the square? Copy and paste somewhere. Sigma SS. So you have all the sigma hard SS right here. 1, 2, 3, 4. 4 numbers. Plus them together. Within treatment, so put this number here. And then it's degrees of freedom, right? So df equal to n-1 times k. If we have equal number of subjects in each condition. So n, in each condition, we have 10 subjects. K is the number of conditions, which is 3, right? So it's 27 to 27 here. And this one. So actually, this stage is the same as what we did, right, in the previous two problem sets. Equals to divide this number minus this number. 100. And df equals to number of cells minus 1. We have 1, 2, 3, 4. 1, 2, 3, 4 cells in total. So 4 minus 1. What's 4? It's not just sorry. Yeah. Which equals to 3. 3 there. And this cell we don't need to compute. And then the stage 2, determine the numerator for 3 F ratios. So the numerator is here. The MS factor A, MS factor B, MS interaction, respectively. So for factor A, right, SSA equals to T rows. So T row here, these two numbers are T what? Rows equals to 2, 2, 2. So here, the first row, T, the first row, which is 50, right? 50 square. You wipe the number of subjects. Here is the number of subjects in each row. So because we have 10 subjects in each cell, so 2 cells together, which is 10 plus 10, which is 20. Plus, because we have to compute the sigma, right? Also for the second row. So just replace this number as 70, this number here, and then minus the g squared divided by n. Use your calculator so you can know this number equals to 10. 10 here. And df equals to the number of rows minus 1. Which equals 2 minus 1. 2 minus 1 equals to 1, right? And SSA equals to not MSA equals to the SSA divided by the DFA, which is just equals to 10. 10. Okay. So let's compute the factor B. Factor B. Similar, but we need to use the column total instead of the row total. So actually this number is 60 and 60. The result, if we do the computation, is 0. Actually, it's obviously it's 0, right? Because they're because the total right there the same. Huh. Here should be 3. I just type in the wrong number. So you can see here the mean they're the same. The null hypothesis for main effect is their magnitude. The mean they're the same, right? Means the difference is 0. So df equals to the number of columns minus 1. Still 2 minus 1 equals to 1, right? And then got to put the number 0 and 1, and then 0 divided by 1 for its ms. Equals 0. Put 0 here. And then we need to compute the interaction by just simple subtraction, right? Subtract the SSA and SSB from the within treatment variance. So for the within treatment variance, which is no from the between treatment variance, sorry, 100 subtract SSA, which is 10, and then subtract SSB, which is 0. So left over, which is 90. 90 here, and degrees of freedom computational formula equals to dfa times dfb. It's this number times this number. 1 times 1. 1 times 1 still equals to 1. And then compute its variance, the MS, which equals to I forgot to compute the denominator of the within treatment component, right? Within treatment, this number divided by this number, which equals to 5. Equals to 5. So, and then we need to compute 3F ratios. Very simple. We just use the MS, right, for each column, divide by the MS arrow term, which is the within treatment. So here MS we have 10 divided by 5, which equals 2. And this is the degrees of freedom of the numerator, which is 1. Degrees of freedom of the denominator, right, which is 36. And it's the same because all of them are ones. But the first number is 2. And here, what? Just why change? Okay. Equals to 0 divided by 5, which is still 5, 0. 90 divided by 5, right? 90 and 5. Which is 18. So this one is 0. This one is 18. Yeah, we're done for this table. Okay, what's the critical region of the main effect of factor A? So it's which critical region, right? So we know critical region of F distribution with df. Check the table. It's not I'm sorry, just copy the framework. So see here, all of them are 136. Right, it's the same thing for the 3 questions. And alpha equals to 0.05. Check the same table, right? One. I don't have the number here, but you do have the number on your book. You do have this number. Well, which equals to F greater than 4.11. Check your book. Same thing for all of these questions. So let's compute 2. F equals to 2, which is smaller than this one, means our right. If you know the answer, you don't need to write so many sentences. You just tell me the critical region and tell me yes or no. Equals to 2, which, right, 2 is not greater than 4.11. It's not in the critical region. Failed to. It means the main effect of 8 is not significant. And similar thing right here for the factor B. 0, so we fail to reject. Here, I got it. This number is 18, right? So 18 for sure is greater than 4.11. Okay, we finished this problem set. Let's go to the next one. Correlation and regression. So Pearson R, right? If you see here, you know I'm talking about the correlation. So correlation, which is the chapter 15. So we finished chapter 14, and then let's start to do the chapter 15. So to compute the Pearson correlation, I can give you the page number. Which is page here we have the formula. R equals to SP divided by the square root of SSX and SSY. SP, I'm calling right? Yeah, it's 10. So square root SSX we have, SSY we have. Use your calculator, and then we know it's 0.81. Done. Is this correlation significant? Use alpha equals to 0.05. So for this one, you need to use the appendix B.6, which is page 657 of the textbook. For R is EF equals to N minus 2. N is how many subjects in total, right? 1, 2, 3, 4. 4 minus 2, which is 2. And alpha equals to 0.05. Here we are going to make a decision. So let's find Pearson correlation table. Here we can close. Pearson correlation. So here I tell you it's a two-tailed test, right? So you check this one, two-tailed test, 0.05. Degrees of freedom as 2 means the critical region is R two-tailed should be smaller than 4. Point. And see here our number R equals to is not in the region. So it's not. So why it's not significant, you can check, right? We fail to reject H0. That means the correlation is not significant. Okay. What percentage of variance of Y can expand planet? By X. So here, to compute the percentage of variance can be expanded by X, we need to compute the R square, which is, you can find it at page 500. So just compute the R square as the square of the R value, right? Which equals to 6%. Okay, we finish. So here the regression equation means is a regression, so means we finished chapter 15. We need to use the chapter 16 here. Regression function. Here we have the formulas. Also, we have this information on your book. Use which is the page. Here, first we compute b, right? For a linear equation, b is the slope. SP we know here, which is 10. SSX we also know here, which is 9. So the answer is 1.1. And then we compute the A, right? Which is my by the minus b times mx. My is the mean of y. So just simply compute. My equals to 2.5. P equals to 1.1 times here 4 plus 1 plus 1 plus 1. No, 4 plus 1 plus 1 plus 4, which is 10. 10 divided by 4, which is also 2.5. So A equals to negative 0.27. So here, so the linear equation, right, which is y equals to 1.11 x minus, to just put the b and a into this linear equation. Based on this regression equation, so let's do the prediction. So it's easy. It's a simple math. Replace the x as 3. Solve it, which is, so the answer is 1.088. Okay. You can also find this one at your page. Right. So here is to fill out summary table, which is page also here. forgot this page number as well. Let me see, what's the page number of this one? Right. So here is the hypothesis testing using the regression. So let's start with here. Analysis of regression, right? The SS total equals to the SSY, just the total variance of Y. So we put the SSY here. We have number here, 17. And DF total equals to N minus 1. Which is, how many subjects do you have? 1, 2, 3, 4. 4 minus 1. 3. For the regression, the component equals to R squared times the SSY, right? So R squared, we have this number computed here, which is 0.66. SSY we have as 16. So the result should be 1.2. And then the DF regression is the number of predictors. So because the equation here, we just have one predictor, right? Just the x, so it goes to 1. MS regression equal to its SS divided by the DF, right? Which equals to zero itself. And this one the received part. You can use this formula to compute. What did I cut? Also, you can just use the simple subtraction. minus. Just need your answer, right? You don't need to write down a lot of formula if you are very confident about your answer. And its degrees of freedom here. So n we know which is 4, minus 1, and then minus 1. 2. So it's ms. Compute the ms equals to 5 point. This one divided by this one. Finally, we can compute the F ratio. So this, put it here. So the F ratio, EF of the numerator 1, EF of the denominator 2, and F value. So we finished this table. Okay. The last question. If an additional predictor x2 explained by an additional 10% of variance and then of y, with the ms residue as 0.05. And is this predictor significant? So for this one, you can find the answer at page 'So this part, the SS additional Excess additional equals to the r square, the delta r square, delta. Here we know it's 10%, right? It's 0.1. Times SSY, we know it's 17. So the answer is 1.7. And then we compute its DF additional as the number of additional predictors. So we just have one addition predictor, right? So equals to 1. And the MS additional equals to its ratio, their ratio, 0.7 divided by 1, still 1.7. Put this number here. And then we have this number here, right? So it's 3.4. And then we want to make the prediction, is this predictor significant? So we need to identify the critical region. To identify the critical region equals to FS DF additional, right? 1. But DF2, how can we compute? Is the number of the residue part. But because we add an additional formula, the additional predictor, so we need to check the formula. So here, n equals to 1 minus f1. So it's n equals to 1. Not df1. Regressor. Here we have 2 regressors in total, right? And which is 4. So this part equals to 1. This part is important. You need to recompute, right, the residue, the degrees of freedom of the residue. So let's check. Still alpha equals to 0.5. Means the critical region is 1 and 1. Average, right? 1, 1. So should be f greater than So this number is not in the critical region, right? Because it's not greater than 161, so not significant. Follow the same logic. Okay, we finished this problem set. The last one, right? Last one. So here is the frequency table. Means we need to use the chapter 17. Which is the password test. So this one, because read the question first. The following data show the favorite place of lunch for students in Queen's College in. Because we just have one sample, right? So this is the, because we just have one sample. So, and then it's a frequency distribution. Goodness of fit. This is name. You cannot just write the chi-square. You have to write chi-square test of goodness of fit, the full term. So here we talk about the predicted frequency, right? You can find it at page 563 to 565. Because we just have two categories. C equals to 2, right? Two categories. So the non-hypothesis here, so our prediction is no preference. No preference means the equal proportion. The non-hypothesis should be P1 equals to P2 equals to 1 over 2, which is 50%, right? So here, the expected distribution is 2P. P times N. P we know, right? And N here N equals to 90 plus 10, which is 100. So the FE equals to P times N the answer 50 and 50. To the data, right? We finished this one. The question 1. Do the data indicate that students have a significant preference over the 3 places? So this is the hypothesis testing part. check your book. Check your book. Page 'You have to organize the data in this way. The expected frequency, right? So this is the formula we need to compute I². So for each cell FE, this is FO, this is FE. So use this formula, we can do the simple computation, which equals to $90, right? 90 minus its FE, which is 50 square, also divide by the FE, which is 50, plus here should be 10, which equals to what? Where is my answer? Where is my answer? And because we need to answer whether or not it's significant, right? So means we need to do the hypothesis testing. We need to compute its df equals to c minus 1. C we know equals to 4 minus 1 equals to 2. Just 1. And then we need to check the appendix B.8 for the transfer table. So it should look like this. So this is a df. Degrees of freedom is 1. And alpha equals to 0.05. So it should be the square greater than what was my number? Equals to 1.05. 3.81, 84. So here our that's where right we our which is in the critical region. So yes, so the student So yeah, let's report the result in APA format. Students have had among quite 3 places. 2. In the essay, dinner and faculty club accused. This is our conclusion. So let's report the result. Square equals to the degrees of freedom, right? And n equals to 100 equals to number 64 because it's significant. So p is smaller than 0.05. It's doing the higher preference compared to the faculty club. Right, finish this part. So the last question. This data show the favorite place for lunch for professors, right, in the Queen's College. Professors means it's another sample. So here we have 2 samples as our data. One is the student, another one is the professors. So because we have 2 samples, and then we want to compare the preference between these 2 samples. So this one is the chi-square of independence. So you have to make sure, right, who report it's of independence. Cannot just write chi-square. Then let's compute the expected frequency. We can use this one as the computational formula. So before we have this computational formula, right, you have to organize the SE, the FE, the FO also into this kind of table. This is observed frequency because we need to compute the row mean and the row total and the column total. So we organize the data, which is 90, 10, 10, 40, right? It's the data we have. And then we have to compute its total. equals to 90 plus 10, which is 100. Right, this 10 plus 40, which is 50. So this is the so this is row, not C. Also 90 plus 10, 100. 2. This is column. 10 plus 40 equals to 50, right? And then for each cell, we do the computation. Here is 100. You can write this information in the exam, right? You can use this formula in another scratch paper. Just give me the numbers. N equals to 150, so which equals to 7. For this cell, right, because the C is 100 and 50, right? The FC is 50, the FR is 100. So this one equals to 3. And also for this cell, it's 100 times 50. This cell, 50 times 50. FC equals to 50, FR equals to 50. So here should be, I have additional 3. We have the expected frequency computed. And then let's also need to do the computation, right? Chi-square use the same formula just to do more computation. So check here, the first column, FO is 90, and this one is 66, the FE is 66.7. Also here is the 66.7. It's the first cell, and then go to the second cell, this one and this one. 10. $40. Just use your calculator to compute and have the answer. And then same thing, degrees of freedom. So for here, you have the formula. R is the number of rows. That's 1. C is the number of columns. Degrees of freedom still equals to 1. So you can use the same number, right? Oh, not here. The critical region for df equals to 1, alpha equals to 0.05. So the critical region is this. The same conclusion. R of chi-square equals to 73.25. So it's greater than 3.84. Means it is in the critical region. So we do have a significant difference preference between students and professors. Okay, that's it. Well, we use about 2 hours to finish the closed book part. Hope you can finish this part quickly in the final exam. So just to do more practice and get more familiar with this computation. Right. So enjoy this video and hope everybody can have a good score in the final exam. Bye.